Let's start by drawing a graph of this situation, and you can see there that there's some keywords there. Parabola. This is after being launched from the ground, and there's some information. Reaches a height of 80 meters after 6 seconds, and the flight lasts 16. So from that, we've got enough to be able to draw a graph of this situation. So where we've got time here, height there, and the path of the parabola, something like that. And the flight time is 15 seconds. So it starts there at 0, 0, and finishes there at 15, 0. And we're told that after 6 seconds, which maybe is about there, 6 seconds, it reaches a height of 18 meters. Now, what we need to know about parabolas is that parabolas have symmetry. So that means this point here is a line of symmetry, and that occurs at 7.5 meters. And therefore, the highest point actually is reached there. And that's after a time of 7.5, not meters, after a time of 7.5 seconds. Right, so what we need is we need a model of the parabola, and if we use this, where height equals t, and t minus 15, but what we don't have is we don't know the maximum height, we don't know the scale of that graph, so I'm going to put an A in front of that to indicate that that's what's going on. It is an upside down parabola, we can see that. We could put negative A in front, but this will sort itself out. So to calculate A, we put in the information that we do have. So what we do have is we have T is 6 and H is 18, so we can substitute that in there. 18 is equal to A times 6, 6 minus 15, and 6 minus 15 is 9, and that's actually negative 9, so 18 equals A6 times negative 9, which is negative 54, so 18 is equal to negative 54 A, and therefore A is equal to negative 18 over 54, which is negative 1/3. So the equation for the parabola we now have is negative 1/3. See the negative there, which indicates an upside down parabola. Negative 1/3 t minus 15. So we've got the model, and it's got use algebra to show that the maximum height reached by the Tory rocket is 18.75. So to do that, maximum height, as we've already indicated, occurs at 7.5 seconds because it lines up there. And therefore height equals 1/3. We substitute 7.5 into that. And if I use the calculator just to work that out, so negative 1/3 times 7.5, and that actually is times negative 7.5 there as well, and that's equal to 18.75. Finished. Now, that's BII, so we've done that bit. So now we'll switch and we'll have a look at the second part. So another rocket is also launched from the ground. After 4 seconds, it has reached a height of 15 meters, and 4 seconds later, it has a height of 18 meters. What is the duration of the flight for this rocket? So it's a slightly different problem. We've got some information. It's also launched from the ground, but after 4 seconds, it has reached a height of 15 meters. So 4 seconds, 15 meters. Then 4 seconds later, which would be 8 seconds, it's reached a height of 18 meters. What is the duration of the flight of this rocket? So again, so we'll start that over here. So let's have a look at another graph. And what we've got there is, now what we're after is what is the duration of the flight for this rocket. So that's when it returns to ground. So we're trying to work out what that point there is. So it starts from the ground here. We're told that after 4 seconds, it's reached a height of 15 meters. So we can model that here. So this can be 4, 15. So we've got height here, time here, and then 4 seconds later. So now, no idea where that is, but we'll put 8 and 18. So we've got 2 sets of information. So we can do the same thing we did before, and let's create a model of that graph. So h equals, and I'm going to put that a in there again, and there's t here, and then t minus some unknown, and I'll make that lowercase a, because that's what that amount is there. So what we're actually trying to find is that a there. So they match here and here. Right, so we have 2 sets of information now to substitute into our equation. And one of those is, if I put that down as coordinates, is 4 and 15. I'll do that over there, 4 and 15. And the other one is 8 and 18. So we need to put both of them in, and we'll create 2 separate equations. So h, so we'll start with the first one, 15 is equal to a, so that times 4, and then 4 minus a. So let's expand that out. So that's 16a minus 4a. And then we've also got the other one, which is 18. And therefore 18 is equal to 8. So we get a times 8, and we get 8 minus a. So expanding that out, we get 18 is equal to 64a, and that's minus a 8. So let's take these 2 equations and line them up one under the other, and we need to solve these simultaneously. So 15 is equal to 16a minus 4a, 18 equals 64a minus 8a. So I'm thinking if I double this one, so if I label that one P and this one Q, if I multiply that by 2, I get 30 equals 32a minus 8a. Then I can subtract one from the other, so I'm now going to go 2p minus q, so 30 minus 18 is 12, and that gives me negative 32a, and that cancels out really nicely. So we've got those missing, and then a is equal to, we're going to get negative 12 over 32, which simplifies to 3/8. Negative 3/8. So that's what a is equal to. We can substitute that into any one of these other equations to calculate what a is equal to. So we can put that into that first one. So 15 equals 16 times negative 3/8 minus 4a times negative 3/8. We multiply that out. It's negative 6. Three over 2. And we're nearly there. So we've got 21 actually, so that's 21. 3 over 2a, and we've got a is equal to 21 divided by 3 over 2, which is 14. And that actually is the answer we're after. So a is 14, so when does it return to the ground? After 14 seconds.